This is the 7th video installment in the Math I released test EOC review in 2014. We're going to go back to number 15, which I had accidentally skipped earlier in the videos. All right, so Alex walked 1 mile in 15 minutes. Sally walked 3,520 yards in 24 minutes. In miles per hour, how much faster did Sally walk than Alex? Okay, so we're comparing the speeds of Sally and Alex, and it says specifically in miles per hour. So the first thing we need to do is convert both Alex's speed and Sally's speed into miles per hour. So for Alex, he walked, and remember, number 15 is still in the non-calculator portion, so we need to do our calculations by hand. So for Alex, he walked 1 mile in 15 minutes. Okay, so we're going to convert that. Miles, we're good there, okay, because we want it to be in miles, but we need to change the minutes to hours. So I know that there's 60 minutes in 1 hour, okay? The minutes cancel, and I'm going to get 60 over 15, which simplifies to 4, and I have miles over hours, so that's going to be 4 miles per hour for Alex. Okay, next I have Sally. Okay, and it says that Sally walked 3,520 yards in 24 minutes. Okay, if you notice, it gives us the conversion for yards into miles. Okay, so 1 mile is 1,760 yards. And if you look, 3,520 yards is 2 times this right here. Okay, so that means that he walked 2 miles in 24 minutes. Okay, we can also further simplify that. So if he walked 2 miles in 24 minutes, then he walked 1 mile in 12 minutes. And now we need to convert this to miles per hour like we did with Alex. So there's 60 minutes in 1 hour. The minutes cancel, and we end up with miles per hour, and we have 60 over 12 miles per hour, and 60 over 12 simplifies to 5 miles per hour. So we have 4 miles per hour for Alex, 5 miles per hour for Sally, and the question said how much faster did Sally walk than Alex? So Sally walked 1 mile per hour faster. All right, next, I also noticed that I missed 34 and 35, so we're going to go back and do those. 34, a company produces packs of pencils and pens. The company produces at least 100 packs of pens each day, but no more than 240. So for each of these, as I read these statements, I'm going to write out a little, like a shorthand version. So for pens, okay, it says they produce at least 100 packs. So they produce at least 100 packs, but no more than, so less than or equal to 240 each day. The company produces at least 70 packs of pencils each day, but no more than 170. So for pencils, they have at least 70 each day, but no more than 170. A total of less than 300 packs of pens and pencils are produced each day. So however many packs of pens plus however many packs of pencils, it says that they do no more, or I'm sorry, a total of less than 300. So the most would be 299 total. Each pack of pens makes a profit of $1.25 for pens, okay, and 75 cents for pencils. What is the maximum? That means the most profit, okay, the most money they can bring in each day. Okay, so I know that however many pens times $1.25 plus however many pencil packs times 75 cents each, that'll give me the maximum profit, okay, or the profit made. So I want to put as many pens and pencil packs that I can. That's going to give me the most money. Now, if you notice, with pens, you're going to make more money with pens because the number right here is larger. You make more of a profit with pens. So you want to make as many pens as you can. So my initial thought is to say, okay, well, I want to do, here it says that I can make up to 240. So obviously, if that's, if the pens are going to give me the most profit, then I want to make that 240 items for pens. But here's the problem with that. If you choose to do 240 pens, okay, if you notice, right here it says that pens plus pencils has to be less than 300. So if you choose to do 240 pens, that means that you're going to make 59 pencils. And if you look back at the pencils, you have to make at least 70. So that's not an option. So instead, let's look at the pencils. Because I have to make 70 of those. All right? So let's go ahead and for the pencils, I'm going to put 70 in for that. Okay? So if I do 70 pencils, then let's go back and look how many pens can I make. Well, I have to do it less than 300. So if I make 70 pencils, then that means that I can only have 229 pens. Okay, because if you add 70 pencils plus 229 pens, you're going to get 299 items total, which goes along with this statement here, that all the pens and the pencils added together has to be less than 300. Okay, so back to this equation right here. So I have 70 pencils, 75 cents each for the profit, and then 229 pens with $1.25 each for the profit. Okay, now this is in the calculator section, so you can put it in your calculator. So I'm going to put 229 pens times $1.25 each plus 70 pencils times 75 cents each. Okay, so that would give me a profit total of $338.75. So that's the largest profit I'm going to be able to make and still be within those constraints that they gave. All right, 35. John mixed cashews and almonds. John bought 4 pounds of almonds for a total cost of $22. The cost per pound for cashews is 60% more than the cost per pound for almonds. John bought enough cashews that when he mixed them with the almonds, the mixture had a value of $6.50 per pound. Approximately what percent of the mixture by weight was cashews? Okay, so let's go back to the beginning here. It said that he bought 4 pounds of almonds for a total cost of $22. Okay, so that means that for almonds, he spent $22 for 4 pounds. So I'm going to divide 22 divided by 4, and that's going to give me the price per pound for almonds. All right, so almonds cost $5.50 per pound. Okay, that's helpful because at the end, we're looking for, it said he bought enough cashews that when he mixed them with the almonds, it had a value of $6.50 per pound. And then we want to know what percent mixture was cashews. So in order to eventually get there, we need to know how much per pound the almonds are and then how much per pound the cashews are. So we just figured out the cost per pound for almonds. Now it says the cost per pound for cashews is 60% more than the cost per pound for almonds. So for the cashews, what I'm going to need to do is take the price of the almonds, $5.50 per pound, plus it's going to be 60% more than that cost as well. So then I need to take that cost and multiply it by 0.6. Okay, because if you have 60%, that's the same as 0.6. And if I multiply 0.6 times that price per pound, it's going to give me the 60% that I need to add to the original price to get the cost per pound for cashews. So I'm going to put $5.50 plus 550 times 60%. So for cashews, the price per pound is $8.80 per pound. All right, so for almonds, we have $5.50 per pound. For cashews, we have $8.80 per pound. Now it says that when he bought the cashews and the almonds, he mixed them together. And then total, the mixture had a value of $6.50. So basically what that means is he did $5.50 times whatever the percent of almonds plus $8.80. I'm going to move this out of the way of my writing there. Times the cashews. Okay, and this is the percent almond, percent cashews. And that's going to equal a total of $6.50. Okay? Now, the question says approximately what percent of the mixture by weight was cashews. All right. Now, there's several ways that we can do this. The easiest option, though, at this point is to do guess and check. So this is talking about the potential prices for cashews. So what I'm going to do is if I do 20%, right, cashews, so 0.2 for cashews, then that means that 0.8 is going to be almonds. Okay, because total it has to be 100%. If I have 0.25 cashews, then that's going to leave 0.75 almonds. If I do 0.3 cashews, that's going to leave 0.7 of almonds. And if I do 0.35 cashews, that's going to give me 0.65 of almonds. So what I'm going to do is plug in these different percentages into my equation here and see which one actually gives me $6.50. So for the first one, I'm going to do $5.50 times the percent almonds, okay? And in our first option here, it says that we have 0.8 almonds and 0.2 cashews. So I'm going to put 0.8 almonds plus $8.80 times the percent cashews, which would be 0.2. Okay, and if that were the mixture, I would have spent $6.16, okay? And that's not our price here that we're looking for. So I'm just going to keep on going, and I'm going to enter it in. Once I enter all of these in, I'm going to find that the only one that works is C, okay? Because if I do $5.50 times the percent almonds plus $8.80 times the percent cashews, that ends up being $6.49, okay? And it says approximately what percent, okay? And that's the closest that we get. So the answer would be C. All right, so skipping over to number 39. The table below shows the cost of pizza based on the number of toppings. Okay, so for one topping, we have $12, two toppings, $13.50, so on and so forth. What function represents the cost of pizza within toppings? So for our equation, we're looking to fill in y equals mx plus b. So we need to find the slope, and we need to find the y-intercept. So I know that my slope is going to be the change in y divided by the change in x, okay, because that's what slope is. So up here on my chart, if I look, as the toppings increase by 1, the price increases by $1.50 every time. Okay, and this is our x, that's our y, because the cost depends on the number of toppings. So my change in y every time is $1.50 over my change in x, which is one topping every time. So that means that my slope is 150 or 1.5. Okay, so we figured that out here. So we have y equals 1.5x plus we need our y-intercept. Okay, now I know that my y-intercept, my b, is whatever y equals when x is 0. Okay, so if you look over here at x, it's going down 4, 3, 2, 1. If I go down to 0, the number of toppings are 0, then that means I'm going to go down 150 over here. So when my toppings are 0, my price is $10.50 if you subtract 150 from 12. So that means that my y-intercept is going to be $10.50. Okay, now if you put this in terms of the variables that they use, okay, the cost of the pizza per toppings is 1.5 times the number of toppings plus $10.50. So they initially charge $10.50 and then each topping is $1.50. Now this is the equation that we get, but if you look, it doesn't actually match up with any of our answers over there. Okay, now here's the reason why. If you look at, well, first let's eliminate some. So for B, it says $1.50 per topping plus $12 to start. Okay, we know it's $10.50 to start, so it can't be that one. This just says $12 plus the number of toppings. That doesn't match up with our table at all. That means if you had one topping, it would just be 13. If you had two toppings, it would be 14. And that's not the pattern that we see. D just says 12 times the number of toppings. That means if you had two toppings, your pizza would be $24, which is not what we see up here. Okay? If you look at A, this is really tricky because if I were to simplify this expression and multiply 1.5 out, okay, look what I would get. I'm going to rewrite this down here. Okay, if I were to distribute this 1.5 out, I'm going to end up with 1.5 in minus 1.5. And when I combine my like terms here, 12 and negative 1.5, I'm going to end up with 1.5 in plus 10.5, which is the answer I got here. So the correct answer is A. It's just that the way that they have formatted their answer, it looks different than the equation that you got. So sometimes you need to look at the answers and simplify them in order to match up with what you find in your problem. All right, number 40. Paul sells chocolate chip cookies and peanut butter cookies. Baking a batch of chocolate chip cookies takes 1.75 cups of flour and 2 eggs. Okay, so for chocolate chip cookies, this much flour, this many eggs. For peanut butter cookies, this much flour and just 1 egg. Paul has 10 cups of flour and 12 eggs. He makes $4 profit per batch of chocolate chip cookies, and then $2 profit for peanut butter cookies. So he makes twice as much making chocolate chip cookies than peanut butter, and that's because people like chocolate chip butter usually. So how many batches of peanut butter cookies should Paul make to maximize his profit? All right, so if Paul wants to maximize his profit, he makes more selling chocolate chip cookies than he does peanut butter cookies. So using the ingredients that he has, he's going to want to make as many chocolate chip cookie batches as he can, and then use the leftover ingredients to make peanut butter cookies. So let's look here. Paul has 10 cups of flour and 12 eggs. All right, so if you look at the chocolate chip cookies, each one takes 1.75 cups of flour, okay? So what I'm going to do is I'm going to take my 10 cups of flour total, and I'm going to divide it by the cups of flour that it takes to make chocolate chip cookies, and that'll tell me how many batches of chocolate chip cookies I could make. So it says 5.71, so basically he has enough to make 5 batches of chocolate chip cookies, okay? So if he does 5 batches of chocolate chip cookies times 1.75 cups of flour, okay, he's going to end up using 8.75 cups of flour total for his chocolate chip cookies. Okay, so if he uses 8.75 cups for chocolate chip cookies, then he's going to have 1.25 cups left over for the peanut butter cookies. Okay, now let's look at the eggs. So it says he has 2 eggs for each batch. So if he makes 5 batches of chocolate chip cookies, then that's going to be 10 eggs for chocolate chip cookies, which leaves 2 for peanut butter. Okay, so we're making 5 chocolate chip batches. So if we're doing that, because that's going to maximize his profit, then let's look to see how many peanut butter batches he could make with the leftover ingredients. So he has 1.25 cups left over for peanut butter and 2 eggs left over for peanut butter. So if we look at the peanut butter cookies, it says it takes 1.25 cups of flour, which is good. So we have enough flour to make one batch. And then 2 eggs left over. Now, it only takes 1 egg. But once we use the 1.25 cups of flour and 1 of the eggs, all we're going to have left over is 1 egg, and we can't use that to make any batches. So in order to make the most money possible, he's going to do 5 chocolate chip and 1 peanut butter. Our question says how many batches of peanut butter should he make to maximize his profit? And so the answer would be 1 batch of peanut butter. Okay, the sequence below shows the number of trees and nursery plants each year. Which formula could be used to determine the number of trees the nursery will plant next, if the number of trees planted this year now is known? So when we look at the number up here, we try to see what's the pattern. And if you notice, every single time from one number to the next, you're multiplying by 4. Okay, from 2 to 8, you multiply by 4. From 8 to 32, you multiply by 4, so on and so forth. So every single time, you're multiplying by 4. So if you look at your answers, the answer that says that you multiply by 4 every single time is A. Okay, your next number would be 4 times whatever your current number is. 42. There were originally 4 trees in an orchard. Each year, the owner planted the same number of trees. In the 29th year, there were 178 trees in the orchard. Which function can be used to determine the number of trees in the orchard in any year? Okay, so basically what I would do is make a chart in this case. So originally there were 4 trees. That means in year 0, there were 4 trees. Then it says in the 29th year, there were 178 trees in the orchard. All right, so which can be used to determine the number of trees. So each of these equations over here is in y equals mx plus b form. So we want to figure out what m is and what b is. Okay, we know that the slope, m, is the change in y divided by the change in x. All right, if we look at the change in y, okay, so from 4 to 178, the change, it increases by 174. And then if you look at the change in x from 0 to 29, that's a 29 increase. Okay, so our change in y is 174 divided by our change in x, which is 29. Okay, 174 divided by 29 gives us 6. So that means our slope is 6. Now, our y-intercept is whatever y is when x equals 0. And if you look here, when x is 0, y is 4. So that means that our y-intercept would be 4. So the correct equation would look like this. And when we rewrite it in the terms that they give us, that means the number of trees based on the year is 6 times the number of trees plus 4. And we see that answer over here. Another way that you can do this problem is in your calculator. If you hit stat and enter, you can input the years right here. So year 0, year 29, and then 4 trees, 178 trees. Then if you hit stat and you arrow over to calc and select 4, it'll give you the equation right here. Okay, so that's another way that you can do it, either by hand or in your calculator. All right, number 43. The vertices of quadrilateral EFGH are given there. What kind of quadrilateral is EFGH? Okay, so the first thing, you're going to have graph paper available to you when you're taking the exam, so you should definitely ask for it and use it. So for E, I'm just going to go ahead and plot these points. All right, so I plotted the points, and here's the shape that's made. Now, they want to know whether this figure is a trapezoid, a square, a rectangle, or a rhombus. So what I'm going to do is I'm going to look at my figure and I'm going to automatically mark out the ones that don't make sense. So for example, a square, one of the properties is that all of the sides are the same distance. You can pretty much tell looking at this that all four sides are not the same. So I'm going to mark out square. Same thing with rhombus. The definition of a rhombus is that you have four sides that are congruent, but the angles between those sides are not 90 degrees. So here you can see those four sides are definitely not congruent, so you can also mark out D. So our options are either a trapezoid or a rectangle that's not a square. So for a trapezoid, the definition is that you have two parallel sides. All right, so two parallel sides and two non-parallel sides. Okay, for a rectangle, you need two parallel sides and then two more parallel sides. The sides actually need to be, like the width and the length would need to be perpendicular so that a 90-degree angle is formed in each of these. Okay, so I guess I should put, let's see, sides next to each other are perpendicular. So if you notice, we're talking a lot about parallel and perpendicular. So we need to find the slopes of each of these because we can determine if they're parallel or perpendicular. So from E to F, I go up 3 and to the right 3. Okay, so my slope here is 3 over 3, which is 1. All right, so my slope for this line is 1. If I look down here, same thing. I'm going to go up 3 to the right 3. So my slope here is also 1. Okay. All right, so looking at my other sides, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then to the left, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so that means that my slope would be 9 over negative 9, which is going to be negative 1. All right, and same thing for this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then over 9. So that would also be negative 1. Okay. So here's the thing. Now you can mark out trapezoid because you have two parallel sides and then the other sides are also parallel. Okay. So that would leave rectangle. Another good argument for rectangle is that the slopes here are opposite reciprocals of each other, the ones that are next to each other. So for example, this one is 1 and this one is negative 1. Those are opposite reciprocals, which means that they are perpendicular. So you do have 90-degree angles in each of these. So that would mean that it's definitely a rectangle. All right, R is the midpoint of segment PS, Q is the midpoint of segment RS, and then it gives us a diagram. It tells us where P and S are located, and then it wants to know the coordinates of Q. So first I'm going to write down P, we have 8 and 10, and then S is 12 and negative 6. We know that R is the midpoint of PS, okay, and then Q is the midpoint of RS. And they want to know Q. So first, we're going to use our midpoint formula to figure out what R is. And then we'll use our midpoint formula again to figure out what Q is. Okay, this is a formula that you do need to have memorized. But it's kind of easy to remember. All it means, if you want to find the midpoint, you add the x values together of your two ordered pairs and divide by 2. And then you add the y values together and then divide by 2. So to find R, I'm going to add my x values together and divide by 2. Then I'm going to add my y values together and divide by 2. Okay, so 8 plus 12 is 20. 20 divided by 2 is 10. 10 plus negative 6 is 4. 4 over 2 is 2. Okay, so R is 10 and 2. Now I'm going to do the midpoint formula again between R and S in order to get Q. So Q is going to be 10 plus 12 divided by 2, and then 2 plus negative 6 divided by 2. Okay, so 10 plus 12 is 22, divided by 2 would give us 11. 2 plus negative 6 is negative 4, divided by 2 would give us negative 2. All right, so our answer for Q would be 11 and negative 2.